Top 25 Structural Engineer Interview Questions and Answers. Structural engineering interviews test both technical knowledge and practical decision-making. Employers want to know whether you understand load paths, structural analysis, design codes, safety factors, materials, construction coordination, and site challenges. They also check your ability to explain complex concepts clearly, work with architects and contractors, and solve problems under pressure. These questions and answers are designed to help candidates prepare strong, professional responses for entry-level, mid-level, and experienced structural engineering roles in building, bridge, industrial, and infrastructure projects. 1. What are the main responsibilities of a structural engineer? A structural engineer is responsible for designing safe, stable, and economical structures that can resist loads during their service life. This includes analyzing buildings, bridges, towers, foundations, and other structures. The engineer selects suitable materials, checks design codes, prepares calculations, reviews drawings, coordinates with architects and contractors, and ensures structural safety. They also inspect sites, solve construction problems, and make sure the final structure performs as intended. 2. What is the difference between dead load and live load? Dead load refers to the permanent weight of the structure, including beams, columns, slabs, walls, finishes, and fixed equipment. Live load is temporary or movable load caused by people, furniture, vehicles, stored materials, or occupancy use. Dead loads remain mostly constant, while live loads can change over time. A structural engineer must calculate both carefully because underestimating either load can affect safety, serviceability, and structural performance. 3. What is a load path in structural engineering? A load path is the route through which forces travel from the point of application down to the foundation and then into the ground. For example, floor loads transfer to slabs, then beams, columns, foundations, and soil. A clear load path is essential for structural stability. If any part of the path is weak, discontinuous, or poorly detailed, the structure may crack, deflect, or fail under loading conditions. 4. What is the difference between a beam and a column? A beam is a horizontal structural member mainly designed to resist bending and shear forces caused by loads acting perpendicular to its length. A column is a vertical structural member mainly designed to carry axial compression loads from upper floors to the foundation. Beams transfer loads to columns, while columns transfer those loads downward. Both members are critical, but they resist different types of forces and require different design checks. 5. What is bending moment in a structure? Bending moment is the internal force that causes a structural member, such as a beam, to bend when external loads are applied. It depends on the load magnitude, position, support conditions, and span length. Engineers calculate bending moments to determine the required size, reinforcement, and strength of beams or slabs. If bending moment exceeds capacity, cracks, excessive deflection, or failure may occur in the structural member. 6. What is shear force in structural analysis? Shear force is the internal force that acts parallel to a cross-section of a structural member and tends to cut or slide one part of the member relative to another. It is especially important near supports and concentrated loads. Structural engineers check shear force to ensure beams, slabs, and columns have enough capacity. In reinforced concrete, stirrups are commonly provided to resist shear and prevent sudden brittle failure. 7. What is the purpose of factor of safety? The factor of safety provides an extra margin between the expected load and the actual failure capacity of a structure or member. It accounts for uncertainties in material strength, construction quality, load assumptions, workmanship, and environmental conditions. Since real structures are never perfectly predictable, safety factors help reduce risk. A properly designed structure should not only support normal loads, but also remain safe under unexpected or extreme conditions. 8. What is the difference between ultimate limit state and serviceability limit state? Ultimate limit state checks the strength and safety of a structure against collapse, failure, overturning, or rupture. Serviceability limit state checks whether the structure performs comfortably during normal use. This includes deflection, vibration, cracking, settlement, and durability. A structure may be strong enough but still unacceptable if it vibrates too much or cracks excessively. Both checks are necessary for a safe, functional, and long-lasting design. 9. What is reinforced concrete? Reinforced concrete is a composite material made by combining concrete and steel reinforcement. Concrete is strong in compression but weak in tension, while steel is strong in tension. By placing steel bars in areas where tensile stresses occur, the member becomes much stronger and more ductile. Reinforced concrete is widely used in slabs, beams, columns, foundations, retaining walls, and bridges because it is durable, economical, and versatile. 10. Why is steel reinforcement used in concrete? Steel reinforcement is used in concrete because concrete alone cannot resist tensile forces effectively. When a beam or slab bends, one side experiences compression while the opposite side experiences tension. Steel bars are placed in the tension zone to carry those tensile stresses. Steel also improves ductility, crack control, and structural performance. Without reinforcement, concrete members could crack suddenly and fail under bending, shear, or tension. 11. What is the difference between one-way slab and two-way slab? A one-way slab transfers load mainly in one direction, usually when the longer span is much greater than the shorter span. It bends primarily along the shorter direction. A two-way slab transfers load in both directions when the slab dimensions are more balanced. Two-way slabs are supported on all sides and bend in both directions. The type of slab affects reinforcement layout, analysis method, and structural design. 12. What is a foundation and why is it important? A foundation is the lower part of a structure that transfers loads safely from columns, walls, or frames into the ground. It is important because even a strong building can fail if the foundation is weak or unsuitable for the soil. Foundations prevent excessive settlement, sliding, overturning, and bearing failure. Structural engineers choose foundation types based on soil capacity, structural load, groundwater conditions, and project requirements. 13. What are the common types of foundations? Common foundation types include isolated footings, combined footings, strip footings, raft foundations, pile foundations, and drilled shafts. Isolated footings support individual columns, while combined footings support closely spaced columns. Raft foundations spread loads over a large area, and piles transfer loads to deeper, stronger soil layers. The selection depends on soil-bearing capacity, load magnitude, settlement limits, groundwater level, and available construction methods. 14. What is soil-bearing capacity? Soil-bearing capacity is the maximum pressure that soil can safely support without shear failure or excessive settlement. It is determined through geotechnical investigation, soil testing, and engineering analysis. Structural engineers use this value to design foundation size and depth. If the applied foundation pressure exceeds soil capacity, the structure may settle unevenly, tilt, crack, or become unsafe. Proper soil evaluation is essential before final foundation design. 15. What is structural deflection? Structural deflection is the displacement or bending of a member under load. For example, a beam may sag when floor loads are applied. Some deflection is normal, but excessive deflection can damage finishes, doors, windows, partitions, and user comfort. Engineers control deflection by selecting proper member sizes, stiffness, reinforcement, and support conditions. Deflection limits are usually specified by design codes to ensure serviceability and long-term performance. 16. What is lateral load in structural design? Lateral load is a horizontal force acting on a structure. Common sources include wind, earthquakes, soil pressure, water pressure, and impact forces. Lateral loads are critical because they can cause sway, overturning, sliding, or structural instability. Engineers resist lateral loads using shear walls, braced frames, moment frames, cores, diaphragms, and strong foundations. Tall buildings and structures in seismic or high wind regions require careful lateral load analysis. 17. What is the difference between static load and dynamic load? Static load is applied slowly and remains constant or changes gradually, such as dead load or normal floor load. Dynamic load changes with time and may involve vibration, impact, acceleration, or sudden movement. Examples include earthquakes, wind gusts, machine vibrations, moving vehicles, and crane loads. Dynamic loads can create higher stresses than static loads, so engineers must consider frequency, damping, resonance, and fatigue during design. 18. What is buckling in columns? Buckling is a sudden sideways instability that occurs in slender columns under compression. Even if the material strength is not exceeded, a long column can fail by bending laterally. Buckling depends on column length, end conditions, cross-section, stiffness, and axial load. Engineers reduce buckling risk by increasing column size, adding bracing, reducing unsupported length, or using stronger materials. Buckling failure can be sudden and dangerous. 19. What is a shear wall? A shear wall is a vertical structural element designed to resist lateral forces such as wind and earthquake loads. It provides stiffness and strength to reduce building sway and improve stability. Shear walls are commonly made of reinforced concrete, masonry, or steel plate systems. They are often placed around staircases, elevator cores, or building perimeters. Proper location and continuity of shear walls are important for effective lateral resistance. 20. What is the importance of structural drawings? Structural drawings communicate the engineer's design to contractors, fabricators, and site teams. They show member sizes, reinforcement details, connection details, foundation layouts, material specifications, levels, and construction notes. Accurate drawings reduce mistakes, delays, and disputes during construction. A structural engineer must ensure drawings match calculations, architectural plans, and design codes. Clear drawings also help site engineers inspect work and confirm that construction follows the approved design. 21. Which software do structural engineers commonly use? Structural engineers commonly use software such as ETABS, SAP 2000, STAAD Pro, SAFE, RAM Structural System, Tekla, Revit, AutoCAD, Robot Structural Analysis, and ANSYS. The choice depends on project type, company standards, and design requirements. Software helps with modeling, analysis, design, drafting, and coordination. However, engineers must understand structural behavior and verify results manually because software can produce wrong output if modeling assumptions are incorrect. 22. How do you ensure accuracy in structural design? I ensure accuracy by understanding the project requirements, checking load assumptions, following design codes, using correct material properties, and reviewing analysis models carefully. I also compare software results with hand calculations for important members. Coordination with architectural, MEP, and geotechnical teams is essential. Before final submission, I review drawings, calculations, connection details, and load paths. Peer review and quality checks help reduce errors and improve design reliability. 23. How do you handle a design error found during construction? If a design error is found during construction, I first assess the seriousness of the issue and stop related work if safety is affected. Then I review drawings, calculations, site conditions, and available options. I coordinate with the project manager, contractor, and senior engineer to prepare a safe solution. The correction must be documented, approved, and communicated clearly to the site team before construction continues. 24. How do you work with architects and contractors? I work with architects and contractors through clear communication, coordination meetings, drawing reviews, and practical problem solving. Architects focus on space, aesthetics, and function, while structural engineers ensure safety and stability. Contractors focus on buildability, cost, and schedule. I try to balance these needs by proposing structural solutions that are safe, economical, and construction-friendly. Good coordination helps avoid clashes, redesign, site delays, and unnecessary project costs. 25. Why should we hire you as a structural engineer? You should hire me because I have a strong understanding of structural behavior, design principles, safety requirements, and construction coordination. I can analyze problems carefully, use engineering software responsibly, and communicate clearly with project teams. I am detail-oriented, willing to learn, and focused on practical solutions. My goal is to design structures that are safe, efficient, code-compliant, and suitable for real construction conditions. Structural engineer interviews require more than memorizing definitions. A strong candidate should explain technical concepts clearly, connect theory with practical site experience, and show awareness of safety, codes, materials, construction methods, and teamwork. These questions help prepare for common interview topics such as loads, foundations, slabs, beams, columns, deflection, buckling, drawing, software, and problem solving. By practicing these answers, candidates can build confidence and present themselves as reliable engineers who understand both design responsibility and real-world construction challenges.